Good evening, all of you. Welcome to another session on accelerated career experience with WIT. In today's session, we are going to discuss about few services that are required to become a cloud native developer on Azure. Before that, let me introduce myself. Hi, I'm Dr. Juliet, Azure Technical Trainer, part of Worldwide Learning at Microsoft. I have over 11 plus years of experience in IT industry as a developer, as a consultant, and a trainer. I predominantly teach and write in the areas of cloud computing and data mining. I have published my research views in several reputed journals and conferences. I have Preethi Doss with me. Preethi, would you like to give an intro?
Yes, thank you, Juliet. Hello, everybody. Welcome to the session, girls. Very good to have you all join us. I'm Preethi Das, as your technical trainer from Microsoft. I have close to 13 years of experience with banking product development and cloud transformation journey across enterprise. I have worked with Azure, AWS, and Pivotal Cloud Foundry in moving workloads from on-prem to Azure, AWS, and PCF. I have certifications in Azure DevOps, Developer, and AI. And I also have written journals, and I have a patent with secure transactions in social media channels. With respect to the hobbies, I like to stay up to date with latest innovation, and I'm also passionate about D&I activities. So I look forward to always drive initiatives to make a difference in the life of women. So that's about me, guys. So looking forward to interact with you and the session. Over to you, Juliet.
Okay, so give me a minute. Let me share you my screen. Okay, so let's get started for the day. The topic for today, or the topic of discussion today, is to become a cloud native developer. So, in this particular training or in this particular session, I'm going to walk you through several services that are required to move your application successfully to Azure. So this is going to be the agenda for today. Why you really need to go to cloud for deploying your applications, and what type of applications are we dealing with today? Is it a monolithic application or a microservices application? And if so, what options you have on Azure, and what are app services, and what are Azure container services? See, today, we see a lot of organizations moving towards cloud, and we see a lot of migrations going on and a lot of implementations happening on cloud, and each organization has its own justification for going to cloud. Some of them go to cloud, maybe they do not want to spend much capex, and some of them go because it is easier to set up, and some of them go because scalability is easier on cloud, maybe due to self-service, due to on-demand services, and also there are n number of reasons why people go towards cloud. People go to cloud, or organizations go to cloud, because of various services that cloud is offering. See, you want to deploy an application. You have services that makes your deployment easier. You want to manage the infrastructure. So you have services that makes the management of infrastructure easier. Maybe you're a SQL admin. You have certain set of services that helps you to manage your SQL database in a better way. So there are n number of services on cloud that makes the life of a developer easier, that makes the life of an infra guy easier, that makes the life of a SQL admin easier, that makes the life of a data analyst easier. So for all these reasons, people go towards cloud. So in the last 10 years, when you see, we paved the way for cloud computing to be, much more efficient and cost effective. And not only cost effective, organizations have become more agile. They are able to bring in, new features quickly into the market because of the various services that cloud is offering to us. And there are a lot of cloud providers in the market. There's Microsoft, Amazon, and Google. And it's basically the service that matters. People go towards the cloud, uh, go towards a particular cloud provider. So let me just walk you through a particular scenario on why we really need to go for cloud. Let's consider a scenario of an e-shopping application. Assume that you have an application, there is an e-shopping application that is deployed in a particular server inside your on-premise data center, or maybe it is something somewhere it's not on cloud. And you have an application that is running inside a single server. And there are a lot of folks accessing this particular application. They're happy with the application, some eshop.com, they're very happy. And the application is very user friendly, intuitive, so a lot of people have started using this application. But then the application was hosted on a single server, but as the load increased, the server could not withstand the load because the server also has a particular limit. Hence, the performance of the server has started to degrade. What do you think you can do once the performance of the server starts degrading? What comes to our mind? See, the entire load is coming to a particular server, right? So we do not want the application to run on one single server. Why not, I have my application deployed on multiple servers. See, when you have your application deployed on multiple servers, no matter how many users try to access your application, you will have a load balancer that takes care of routing your request to the appropriate server. All right. So, no matter how many users are trying to access your application, based on the routing policy that you have implemented inside your load balancer, the load balancer routes the request to any one of the servers. Hence, the traffic is getting split, or hence, the load on the server is being distributed. See, this is totally fine. This is a very common scenario. But how long do you think it takes for an organization to increase the number of servers and then configure the load balancer and ensure that they put their application up in the market as fast as they could? How long do you think it takes? Definitely, it cannot be done in minutes. Can we say it takes a day, or maybe it takes weeks, or sometimes months? So, if your organization is more process oriented, then again it takes more time, right? Definitely, you cannot scale your application along with load balancers configured in minutes. But if you have your application deployed on cloud, you can have this entire setup done in couple of minutes or in few minutes, right? So how do you think these cloud providers are able to do it in minutes, whereas we at on-premise are not able to do as fast as they could? It is because of the various services that cloud is offering to us. So that is what we said. Cloud is offering us n number of services. So that is making the life of developers, that is making the life of infra guy admins, it's making everybody's life easier, right? So same here. Even the load balancer is offered as a service because of the services cloud is offering. You know, people, we are able to quickly put our product into the market. Now, can I not have this setup done on premise? Can I not scale it on premise? Can I not bring in high availability on premise? What if your application is on premise, and what if your application is on cloud? See, I can increase the number of servers if my application is on premise. I can bring in high availability even if my application is on premise. Whatever is happening on cloud, I can also do it on premise. But the only difference is if it is on premise, it is your responsibility to do that. You will have to take care of the underlying infrastructure. You will have to do the maintenance. Of course, you can scale. Instead of one server, you can go ahead and provision two or three more servers. But then scalability takes a lot of time, and then you can bring in high availability. But again, those who have really configured disaster recovery, so the pain of it. It's not, you cannot just do it within few clicks on your on premise. So the entire setup is time consuming, and you spend a lot of capital expenditure, and then it takes you know and it's more effort also. But when you have your application on cloud, so it is the cloud service provider who is going to manage the entire infrastructure for you. And especially on applications like, PaaS, you can scale your application in minutes. So in cloud, we have different types of applications. We have infrastructure as a service, we have platform as a service, software as a service. So it gives you various options. So we are just focusing on PaaS for today. So when you have your application on PaaS, it just takes few minutes. You just tell them, okay, I want three more instances, and then you get it done. You do not have to, take care of maintenance. It is taken care. And then high availability. Yes, sometimes for certain services, cloud offers you some basic level of high availability, and then it gives you more controls to extend that. We are going to focus on those services that helps you to deploy your application easily on Azure. So when we talk about deployment, there are n number of services on Azure that you can leverage for deploying your application. So we have a web app service, we have API app service, we have container service, we have Kubernetes, service fabric functions. So if it is just an application that you're trying to deploy, if it is just a code that you're trying to deploy, just go ahead with your web app service. Or if you have created some RESTful services or web APIs, you can go ahead and get your application deployed using the API app service. What if I have containerized my application? It is a Docker image. So, do I have any platform wherein I could go and deploy my application? Yes. So, we have an Azure container instance. What if I'm developing an enterprise application and I have 50 services or hundreds of services that needs to be deployed and some sort of orchestration is required? You can go ahead and use Azure Kubernetes. And again, even for microservices, we have one more option, which is your Azure Service Fabric. And then you have functions. What if you have extremely small services, or you just have a piece of code and you're looking for a platform to run that code on Azure or on cloud? So you could go ahead and leverage Azure functions. So these are various services that Azure offers to you, and these are more focused towards deploying your application and managing your application. So these services, when you use these services are platform as a service offerings. So you're not going to manage the underlying platform here. It is completely taken care by Azure itself. You just send your application, and these services has got some services. They try to take the metadata of your application and then find out what application it is, what version of the class libraries it is using, and then it spins up a VM with those metadata information wherein your application can run. All right. So we will, in this training session, we are just going to focus on two different deployment services. One is your web app service, and the other one is your Azure container instance. See, we have different platforms wherein you could go ahead and get your application deployed. But then, before even getting our application deployed, you should first understand what application you're using. So there are different ways in which you could architect your application. So whether your application is a monolithic application or is it a microservices application. So this is something that is very important. So this is something that needs to be taken care at a design level itself. All right. So let's just quickly see what is a monolithic application and what is a microservices application. So these are, microservices is a very common terminology that we are hearing these days. Anyways, so what do you mean by a monolithic application? See, we discussed about the challenges faced by the e-shopping application couple of minutes before. Let's assume this particular e-shopping application has got a module. Maybe I call it as a login module, and there is a checkout module, and then there is a product search module. Okay. Now, in a monolithic application, all the functionalities are packaged together inside a single container, or you can say it is packaged together inside a single process. Okay, so they're basically packaged together. All right. Now, let's assume a lot of people are accessing this e-shopping application. A lot of people are accessing, and mostly, people use the search functionality, whether they shop or not, they keep on searching. Okay, what is the latest, product, this one, and they look at some latest electronic gadgets. So a lot of times we spend time searching for products rather than purchasing, right? So hence, the load or the number of requests that are going to this particular module is more. So let me call this as a choke point here. See, no matter no matter like, you know uh, where the request is going, you need to scale the instances. You just need to scale the entire application as such. You do not have the provision to scale only the product search service module. It is not possible in case of a monolithic application, because all the modules are packaged together as a single instance or a single container. It is not possible. But in case of a microservices, it is possible. In case of a microservices, each and every module is developed independently, and each and every module is in fact tested independently. Each and every module is deployed independently. Each and every module is managed independently. Okay. And each and every module can be scaled independently. And in fact, when we say each and every module is developed independently, and each module can be developed using different technologies. Maybe login service is developed using a .NET, the other module is developed using Java, another module is developed using PHP. So they can be, developed using different technologies also. Because everything is a separate instance or a separate container or a separate process, it is easier, or it is possible to just increase the instance or just increase the service wherein the load is high. In fact, in case of any bugs or memory leaks in one of the modules, let's assume there is a bug in this particular module, or maybe there is a memory leak in this particular module, and that is not going to affect the other modules. So that is just going to affect the performance of the login service module alone. It is not going to affect the performance of the other modules. All right. So before even think of choosing what service I can choose on Azure, first of all, you decide on how your application can be architected. So whether you really want to go for a monolithic or microservices. Now let's assume that you have decided, okay, I have developed a monolithic application. Now you look at the various services wherein these monolithic applications can be deployed. If it is a microservices application, then you look at the various options, that are related to microservices on Azure. So in this training, we are just going to focus on services. What if your application is a monolith? What if your application is a microservice? So what service I should be choosing on Azure? So first, let's look about this monolithic. If at all your application is a monolithic application, then this Azure App Service is the right place for you. All right, it is a right place for you to land on. So Azure App Service is a service with which you can deploy and manage your application. So this is a pure platform as a service offering. You have an application, so you are looking for some environment just to get your application deployed. You do not want to configure the environment. You do not want to spend time configuring the environment. So you're just looking for some environment, or you're looking for some pre-configured environment. So do I have any environment on cloud wherein I can go ahead and simply deploy my .NET application without the need to configure the environment? Yes. So you have Azure App Service. So this gives you a platform or a pre-configured platform wherein you can just go ahead and get your application deployed. So when we say Azure App Service, it's not that it supports only .NET based applications. It supports .NET, Node.js, PHP, Python, Java, and in fact, the list is increasing. And even different versions of each of these technologies. And because it is a pre-configured environment created by Azure, it is not our responsibility to take care of the platform. So Azure had configured it. So it is Azure's responsibility to maintain the platform where your application is actually running. You do not have to take care of that particular platform. All right. So that is one part of it. Now, let's assume, just give me a minute. Okay. See, now my application is getting deployed on Azure. Let's assume, see, once your application is on cloud, it runs inside a particular VM. Let's say, so maybe you can decide whether you want your application to run in a dedicated VM or whether you want your application to run in a shared VM, and how much RAM should this VM have, and what should be the series of VM. Okay, so there are different configurations. We call it as VM series. So what VM series would you like to have, and how much storage space should this particular VM have, or how much storage space should be allocated for your application, right? Not exactly the VM, for your application. So all these decisions you will have to take care before even deploying your application. So this choice that you make, okay, I want a dedicated VM wherein my application can run. Okay, I would like to have a VM which gives us a RAM of 3.5 GB or 8 GB. No, I want to go for an A series VM, and I would like to have a 50 gigs storage space. So these choice, you do not have a provision wherein you could go and mention each of these individually, but then we have something called as an app service plan. So we call it as an app service plan. So with the help of app service plan, you choose, whether you want a dedicated machine or how much RAM or what configuration VM you want. So all these are decided by the app service plan that you choose. And there are, around like 5 app service plans. We'll see about that. See, this app service plan is something that you will have to choose before even you deploy your application. So let me just take you through the portal now. Let me open the portal. Okay. So this is my Azure portal. I logged in using portal.azure.com. Okay. So in order to work on Azure, it is important or it is mandatory. You must have a subscription. So subscription is essential for you to get started with Azure. So without a subscription, you cannot start working on Azure. Okay. Now, once you have your subscription, and only then you get access to this portal, now you can start creating your resources. Towards the left, when I click on this all services, we see the various services that Azure offers. Let me just click on this all. See, these are the various services that Azure offers to us. Okay. As I was mentioning you about the various services, any cloud service providers offers you n number of services that makes the life of different people easier. So these are the various services I was referring. Now, if you click on this web, you should be able to see the various services that are related to web. It can be a deployment service, or it can be certain services that can improve the performance of your application after it is deployed. So there are different services. So we just discussed about this app service. So let me just hit on this app service, and you can go ahead and create a new app service. So this is one way of creating it. Otherwise, you can just go to this menu, click on create a resource, search for web app service here. Okay. So we have a small description here which says app service web apps lets you quickly build, deploy, scale enterprise grade web, mobile, and API apps running on any platform. Okay, so maybe you can read this sometime later. Let me hit on this create to create a new web app. Now let me go ahead and create a resource group. See, any resource, see anything that you create on Azure, we call it as a resource. So that is a terminology we use. See, now that I'm going to create an app service, I say I'm going to create a resource. So anything that is created on cloud is called a resource. Okay. And every resource that you create on Azure must belong to a resource group. I hope you all are able to see my screen. Okay, fine. So every resource must belong to a resource group, and this resource group is nothing but a logical grouping of resources. See, in an organization, or let's assume you might be working on different projects. So you might be working on a project A, and you might be working on a project B at the same time, and you're creating some resources for project A, and you're creating certain resources for project B. How do you logically separate these two resources, that these are the resources for project A and these are the resources for project B, right? So this is done the help of the resource group. So let me go ahead and create a resource group. Hit on create new. Let me name it as WITRG. So these are the resources I'm creating as part of this WIT session. Now just give a name. So this name has to be a unique name. Let me give the name as WIT web. Yes, WIT web. So this is basically witweb.azurewebsites.net. Once your application is deployed, the application will have the URL witweb.azurewebsites.net, but later you can go ahead and change it. And now what are you going to deploy? I'm going to deploy a code or a container. So no worries, container will be discussed next. I'm just going to deploy a code. What runtime? Here you go ahead and choose whether it is a .NET application. If it is a .NET application, is it using some frameworks or is it a core? And if it is Java, what version of Java? If it is a Node, what version of Node? If it is a PHP, what version of PHP? If it is Python, so there are several versions. If you notice here, let me just take the example of this ASP.NET version 3.5. There are other frameworks also, 2.0 and all. But 2.0 is not listed here. So does that mean I cannot deploy an application that was developed using the version 2.0? Hmm? Are you getting my question? See, I have an application that is developed using a .NET framework of 2.0. Okay. Can I deploy that application on cloud or on Azure using a web app service? I cannot do that because it is a platform that is created by Azure. So because it is a platform as a service. So they support only application which has a minimum version, framework version of 3.5. All right. If you're not seeing some older versions here, which means those versions cannot be supported, but we have a workaround for that. I mean, it's not exactly a workaround. That is why we go for technologies like containerization and all those. Okay. Fine. So let me just go ahead and choose something. And in which region you want your application to be deployed? Okay. In which region you want your application to be deployed? Excuse me. So Azure has got data centers across the globe. S- around like 60 plus regions across the globe. You have the provision to choose inside which region your application should be deployed, but you cannot decide which data center inside a particular region. All right. So I say I want my application to be deployed in Central US. So these are the various regions. You can just have a quick glimpse at it. So these are the various regions. Let me choose. So I can choose India also. Now comes the app service plan. Where do we use an app service plan? to decide inside which configuration machine your application should be running, or how much storage should be given for your web application, or how much RAM should be given for your application. So how do you decide on that? So let me go ahead and create an app service plan here. Hit on this change size. So there are various plans if you see. So we have a F is for a free plan. This D is a shared plan. This B is an basic plan. And then we have a premium plan. And we also have one more thing, which we call it as an isolated plan. So this is something that is different. Look at this free plan and look at the shared plan. So both of them say that they have a shared infrastructure, right? So they have a shared infrastructure, and the RAM is 1 GB, and you could utilize only 16 minutes per day compute. Okay. If your requirement is something more than this, then you cannot go for a free plan. Okay. And then we have one more plan, which we call it as a shared plan. Excuse me. So this also gives you 1 GB RAM, but then you can use 240 minutes per day compute. But then you pay around 800 bucks per month. All right. So these both basically have a shared infrastructure, which means when your application runs on Azure, it's not that only your application is running inside that particular VM. You also have other applications running inside the same VM. Okay. Maybe, but inside different application pools. All right. And then we have a basic plan. So from the basic, we have basic plan here. So we get dedicated machines, and all the other plans, we get dedicated machines. So basically, higher the plan you go, you pay more for it, but then you get more features, you get more storage, you get more RAM, you get high configuration machines and all those. Let me just go to this production and choose. So we have the standard plan here, premium plan, and all these. Let me just scroll down. See, look at this. Let me go here. Okay. See, look at this free plan. I only get 1 GB storage. Let me go to the shared plan. I get 1 GB, but along with that, I can also give a custom domain name. When I go to the basic plan, I get 10 GB. Okay. And I can also scale my application. So that is what we were discussing before some time. What if the load on my application becomes high? So you can go ahead and scale it. But with basic plan, you can scale only up to 3 instances, which is 3 servers. When you go to the standard plan, just look at it. You can scale up to 10 instances, and in fact, you can have an auto scaling. You need not manually go and say, I want 3 instances, I want 5 instances, 6 instances. You can just tell there, if the traffic is more, then give me, 5 instances. So you could do some sort of auto scaling. All right. So let me choose the standard plan. And yes, you can go ahead. Okay, this is your GitHub. If you're using some repository. And what if you want to monitor your application? We use something called as an application insight. Go ahead and create a service. So I just created a service on Azure now. By hitting the create button, now it starts getting created. Okay. Now that I have this application, so let me just open this. I will just bring it up. This is a very small, HTML file with just, heading here. Become a cloud native developer. So what if I want to deploy this particular application onto Azure? So what if I want to, move this particular application to Azure? As a first step, I need to identify the service. The identified service is a web app service, and I created that service also. My service is created. Now let me open this. Let me browse this. See, once this app service is created, the name of my app service is web. Once it is created, you have an URL that is generated for this. I'm just, copying this, and okay, so maybe I don't think I'll be able to give you this, but you know, please try accessing this application. Can you just give it in your browser? witweb.azurewebsites.net. Okay. Yes, so it is pinged for you. So just try accessing this application. So there is a sample HTML page that is already deployed once you created that particular service. That is some HTML page. So whatever you're seeing here is a HTML page. Okay. Now, where is this application deployed? If at all you want to know where it is deployed, where is the file server inside which it is deployed? Yes, you can go ahead and see this. So let me scroll down, go to this advanced tool and hit on this go. This is a Kudu engine which lets you access the files inside the file server. Let me open this debug console and go to this. Yes, hope all of you are able to access it. Yeah. There is a site folder. Inside that you have this www root, which is basically, you have this. So those who have, already configured, IIS must be knowing this structure. Let me open this. So what are you seeing here? Hosting start.html. There is a HTML file inside the www root. So that is the file that you're seeing here. Okay, sorry, that is the HTML file that you're seeing in the browser. See, when you gave that particular URL, you saw a page, right? It is nothing but this particular page, which is residing inside the www root folder. Okay, let me remove this. I do not want this file. Instead, I will go ahead and deploy the file that I created. So I'm just dragging this, which is this. Okay, I'm just dragging this and I'm putting it here. Okay, now can you go ahead and refresh this page and you tell me what you see? Are you seeing the old page or are you seeing the new page? You should be seeing this updated HTML page because I removed the one that was there and then I deployed my application, my HTML file. Are you all seeing it? Okay, fine. See, what I did now was I just opened the FTP server. I went to the www root. I just dragged my HTML file and then I dropped it here. But this is not how it works. So for anyone who's new, just to give you and just to make you understand, I directly went inside my FTP server and I showed you how to deploy your HTML application. But in real time, we do not do it in this way. Okay. So in real time, we actually push the artifacts through our CI/CD pipeline, or most of the time it is through the CI/CD pipeline, or we do it using PowerShell. So this is just for us to understand the structure and how things are happening on Azure. Okay, fine. So now that I deployed my application, I deployed my application. But now that I decide, okay, I would like to, you know, I would like to make some small changes in the application. So how do I do that? Just scroll down. So this is just for our understanding. Okay, we have an option called as an app service editor. So let me go here. Okay, and here I see my index.html. This is the one, become a cloud native developer, WIT. That's it. Now let me refresh the page. You should be able to see the changes getting reflected here. Got it? See, that is just an easy way for us to go and edit the files that we have. Usually we don't modify the application code. We don't go and modify the application code. uh, all You cannot do that, right? Because everything will be DLLs once it is deployed. But what if you want to make some changes in the configuration file in your web.config file or the web.xml file? You could go ahead and do these type of edits there. Now let me come back. See, you deployed your application. Your application is running inside a production environment somewhere here. But a lot of times we may not want to deploy our application directly into a production environment. So we want to deploy into some sort of a test environment. Maybe I call it as a test environment, or maybe you can also call it as some sort of a stage environment. Okay, you deploy your application here, you do all the testing and everything here. Once that is fine, and then you move it into your actual production environment. Maybe I call this as a prod environment. But now that when I deployed my application got deployed inside the production environment. A lot of times we don't do that, and we don't want to do that. We want so any new feature implementation or anything that we do, we want to have an environment that is exactly similar to that of the production environment. Do all the changes there, do all the testing there. So once you're fine with all these, then push your application into the production environment or swap it. Okay, so this way of maintaining multiple environments, which is similar to that of the production environment, is what we call it as a deployment slot on Azure. So Azure gives you a provision or offers us a feature which we call it as a deployment slot, wherein it gives us a provision to create environments that are similar to that of your production environment. You need not create another, app service. So let me show you. Yeah. So this is what we call it as, deployment slot. So we have some staging environment, and you will have a production environment. You do all the changes in this particular staging environment. And once you're fine with that, then you're going to swap these both. Okay. And a lot of times, as I told you, our artifacts, come from through a CI/CD pipeline. Even if you have a CI/CD pipeline, that is fine. You can push your from the pipeline, you can push it into your staging. Okay. So we'll see how that can be configured. Let me open the same portal again. Uh, okay. Yes. So let me go to this deployment slots. And you see here, I can go ahead and add slots, which means I'm creating another environment that is similar to the prod environment. Maybe I call this a stage environment. I call it as a stage. And while creating it is asking me, should I just create an environment, or do you want to have the application also cloned along with the environment? So I say, no, do not clone. And now let me hit on add. So this is creating another environment now. So once this environment is configured, so you will have all these options in your staging environment also. Okay. Now let's see whether the staging, and yeah, it is created now. Let me open the stage, and let me hit on this browse. Now you tell me what you're seeing here. I'm pinging you this link. Okay. So this stage link, so you can, this same link, the only thing you add is hyphen stage. Okay. So I have pinged you. So please try accessing this link. So I have a app service that is created. Inside that, I have two stages. All right. And the actual production environment has this cloud native developer thing, and the staging slot has this. Now, what if I'm continuously doing all changes in my staging environment, and once I'm done with that, I can just do a swap. So just you see the swap here, swap option. So let me go to the swap and okay. So I just hit on the swap. So now after a couple of minutes or after 1 or 2 minutes, yeah, after a couple of minutes, once you refresh, you will see the contents of stage coming in the prod and you will see the contents of prod coming in the stage. All right. Can you refresh and see now? Not yet done. Yes, now it has changed. So do you also see the difference? This is not yet changed. Okay. Oh, sorry. I just moved it the one way around. I did not move the other way around. Okay, fine. See, now do you see this, your prod environment having the same content as that of the stage environment? Right? See, in this way, right, you can quickly spin up. If it is on premise, then in that case, you will have to provision a server that is exactly similar to that of the prod, right? But just see how quickly we are able to do this, right? So similarly, we have, lot more options available for our app service. I was able to, show you only few here. So we saw how to deploy and we saw how to create multiple slots. And later, if at all you say, no, why is my domain name always having assurewebsites.net? I do not want that. Fine. You go ahead and then you give a custom domain name. Okay. So we can change that. Okay. And you can, easily scale out. What if you feel, no, I want, instead of one instance, I want 5 instances of my application. Just go ahead and give 5 and save. That's it. Now that you will have your application running on 5 different instances. Got it? So that is, pretty much, so I think I have, taken more time. So we will now see how you can, deploy a microservices application, or how you can containerize an application. So this was, I was just trying to push a code. What if you have an application that is containerized? What option, how you can go ahead and deploy those container images onto Azure? So that's what we are going to do next. So Preeti will be walking you through these topics. Yes, Preeti?
Hey, Juliet. Thank you. Thank you for handing off. And let me go ahead and share my screen. Perfect. I hope all of you are able to see my screen. So I'll be writing on the screen and talking to you guys. So you may see my face turned on the other side. Please bear with me. Okay, so what we have covered so far, Juliet has spoken about monolithic and microservices, right? Breaking the monolithic application into microservices and how much of an advantage that it brings onto the table. So we had a monolithic application, let's say like a fictitious online booking.com application. And now we have broken down into multiple microservices which can run by itself. And the whole concept of microservices, it introduces low coupling and high cohesion. So when you look at the definition of cohesion, it can be thought of analogous to team members working in an agile team. So if team members work in cohesion, you have a high performing agile team. Similarly, bookings.com is divided into maybe reservation API, and we have payments API, and we have notification API, and maybe we have like booking API, right? Um, booking API. So reservation API is something that is going to return back the details of a reservation, and booking is where you would actually, as a user, do the reservation. Notification, you get notifications of your bookings, and payments is the next other API which would interact once you have done your booking. So I saw a question from Satyam Deb, right? So you had a question, hey, what about microservices which are implemented in multiple languages. So let me take your example as a case, and let's say that reservation API is implemented using .NET Core, and we have payment API, let's say .NET Core version 3.1, and payment API is using .NET Core version 2.1. Notification API, maybe it's written in PHP. I'm just giving an example. And bookings API in Java. Okay, 1.8 or whichever version. Maybe it could be 1.11 also. So let's say that these are the 4 microservices which is independently running. And I want to now look at how do I deploy these microservices. Now that I've done my development, I want to deploy it in production. So rather than jumping directly into containers, let me take you a little back, right, 10 years behind, and have you understand before the concept of virtual machines and containers, what did we have? So we had bare metal hardware. You would procure a server. Let's say you started a startup and you're having onlinebookings.com. And in a startup, you would procure servers. That would be the first thing to do. So let's say, like, I procured a Linux server with 8 core CPU and 32 GB RAM. So, onto this bare metal hardware, I would go ahead and deploy all my applications, right? So let's say I'm taking this reservation API and I would deploy the application, but look at it here. Reservation API is using .NET Core version 3.0, 3.1 and payments API .NET Core 2.1. So we have what? A dependency conflict. So you cannot have onto this bare metal hardware, which consists of compute, storage, and network, onto this bare metal hardware, if we were to place both the reservation API and the payments API, would it coexist? So it may not, right? Because we will have a dependency conflict. So now straight away I have to go and deploy only one, and I can cancel this off. But does my reservation API require the entire 8 core CPU? Maybe not. I had initially procured my server to accommodate all of my applications, all 4 applications. But if I had to do the 10 years before, 20 years before, the way that we had earlier done, I may not be able to accommodate all these applications due to the library issues or version issues, runtime issues, OS issues, and such. So I will end up running only one application and not take advantage of the cost that I had invested on procuring an 8 core CPU, right? So, straight shot, this is not an optimal solution. There has to be a better way of doing things. That's where we came into the world of virtual machines. So in virtual machine, if you see, let's say I'm going to discuss about virtual machine in the second box. We have the bare metal hardware at the bottom, which is combination of compute, storage, and network. And on top of it, we have the host operating system of the Linux OS. That is the server's host operating system, which I mentioned as Linux. And we have another component called hypervisor. So the host operating system and hypervisor, it together divides the physical hardware into smaller set of virtual resources. Okay, and you can use those virtual resources to spin up virtual machines onto the server, Linux server. So let's say I'm taking the reservation API and I want to spin up a virtual machine for reservation API. I can do that. The virtual machine will have reservation API sitting right here. And I want to do a payment API. I could still do that. Then I have this payment API sitting right here. How am I able to do that? Like, there is no version dependency issues happening here, because each of this virtual machine is isolated from the other. So the virtual machine internally has its own guest operating system. We have two guest operating systems right here. There is another guest operating system, and applications that is running inside the virtual machines performs system calls um, to the guest OS. Okay, the kernel that is running inside the guest OS. And this kernel within the guest OS would then communicate to the host OS through the hypervisor. So similarly, that is the case for the second application as well, that has a kernel inside. And of course, kernel is the heart of operating system that kind of helps in communicating between the software and the bare metal hardware that resides below. So the kernel is a very important aspect here. However, what happened with virtual machines is that we have this 8-core CPU. By enabling this layer of host operating system and hypervisor onto this bare metal, had consumed around 2 cores. It consumes because you need the host operating system to run some system process, right? So 2 core is consumed by this layer. And the other 2 core each is consumed by each of these virtual machines. 1 core for the application itself, and the other 1 core CPU is consumed by the guest operating systems. Again, as how the host operating system onto this Linux server consumes some amount of compute due to the system process that it has to run. Similarly, the guest operating system for this virtual machine also has to perform certain system processes, which requires additional compute resources in addition to the ones that is consumed by the application itself. Eventually, what has happened? Let's sum it up: 2, 3, 4, 5, 6. So 6-core CPU has been already consumed. There is no room for the other two APIs. Do you guys agree with me? We have solved the problem of isolation, whereas there is no conflict between these runtime versions. However, we have not been able to accommodate all those four applications to be deployed onto my 8-core server. There has to be another better way of doing it, right? So that is where we come to containers. So let's just rub this off. So containers are lightweight processes that can run directly on the host operating system, similar to the one before I had drawn, which is onto the server. We have the bare metal combination of compute, storage, and network. We have the host OS, and since it's a Linux server, I have Linux operating system running. I can create individual container processes that can directly sit on to the host operating system. So thereby, I can accommodate all the four APIs. We have the reservation API, payment, and I have the notification API, and I have the bookings API. And how am I able to do that? Because I'm able to give the entire 1 core of what is consumed by each of this API, along with the fact that the host OS is going to maybe, like, let's say it's going to consume 2 core that we had provided for the previous scenario. So totally 2, 3, 4, 5, 6. We still have 2 more to go. So we were able to accommodate all four containers, which is deploy all four APIs in one single 8-core server. And how are we able to achieve this? Let's talk about each individual container to start with. Like reservation API is running on a single container. And as I told you, a container is nothing but a process which can directly run on the uh, host operating system. So the containers can interact with the same kernel of the host operating system directly, and isolation is also achieved. Each of these containers uh, assume that they are independent processes that is running. So onto this container, you can have a .NET Core version 3.1 running, and it wouldn't even be aware of the fact that there is another API which has .NET Core 2.1 running. So each of it is completely isolated. Uh, how is it that a process which can be thought of any other simple process that you run on a server, uh, be able to spin up an entire infrastructure of its own, right? So there are two things that we want to understand before we move into creation of containers. First, let's identify how the Linux operating system is able to provide the isolation of each of the containers, at the same time ensuring that each of these containers will consume only one core, because when there is more load on the reservation API, it shouldn't be eating up the compute of what is required for other services as well. So when you define that, hey, reservation API needs only one core CPU and whatever capacity that it is supposed to consume, it should be within that limit. So how does the Linux OS, the host OS, takes care of ensuring that? So we have two things. One is namespace. Let's understand what a namespace is. So by default, every Linux system has one single namespace. Okay. And all the system resources, be it the file systems, the process IDs, or the user IDs, network interfaces, belong to the single namespace. You can also create additional namespaces and organize resource across them. When running a process, you run it inside one of these namespaces. Let's say I have, um, let me draw out the host OS and the host OS. And I'm just drawing out namespaces. And this is a namespace for a mount. And we have another namespace for network, and we have one namespace for uh, process, and so on. Multiple kinds of such namespaces exist. So if you want a container, which is also a process, to use a mount namespace, because see, container is end of the day, again I told you, it's just a process. It does not come with an inbuilt storage capacity. When you kill the process, the container is gone along with whatever that you try to store within the container, all the this whatever the file capabilities, everything will be gone. So you need, if you have a scenario where you want to persist certain information, you're writing a job or doing a read write operation, batch process into the container, and you want to persist certain information, you may want to use certain volume mounts, so that even if this container process is killed, when the other container comes, it can be attached to the same volume mount. So remember that there is already a mount namespace. So you can have this process, mapped to each of the namespaces that it requires. So the mount namespace, the network namespace. So when the container is pointed to a network namespace, um, let's say your application have um, uh, you know um, uh, have to be exposed to a particular network. So the next namespace ensures that the process belongs to that single network, and it is completely a private network and nobody else can enter into that network. So you kind of map this process to multiple of the namespaces. It could be system namespace, or you can create your own custom namespace onto Linux system and assign the process to that namespace. So that way what happens is, um, you will have an independent container process running with full isolation. That's the first thing to understand. The second one I spoke about is about ensuring that the compute is not overutilized by one single process. And the process right here, again, let me reiterate, process is nothing but containers that is running. So that is ensured by C groups. So a Linux kernel feature that limits the resource usage of a process is through the C group, so that the process cannot use more than the configured amount of CPU, be it the memory, the network bandwidth, and so on. So you create a specific configuration, and Linux C groups will take care of handling that. Now, I was telling all of this for a bare metal server onto which you go and manually create containers, right? But can a Linux operating system create container directly? No, right? There should be somebody who needs to create container for us to start with. Once a container is created, then you can think about namespaces that can be assigned to the container, and you can think about C groups that can ensure that the containers are limited to that particular compute units. So to kind of help us, create containers within this Linux system is where we are going to talk about Docker. So let's introduce Docker into the topic. Now, Docker is a container platform, which actually was the first container platform, I would say, that made containers more easily portable across different machines. We will talk about portability in a bit. But then remember that one of the biggest advantage of containers is portability. Okay, so here let me also call out, we had established isolation. However, we were not able to handle the uh, optimal utilization of compute. So let me just call out the advantages of virtual machine. Isolation is possible. However, yeah, we did see the disadvantage. Now we spoke about isolation is pretty much possible in containers as well. Additionally, I've written portability here. Now, Docker simplifies the process of packaging up the application along with its libraries and its dependencies and the entire operating system into a simple portable package that is used to provision the application in any other machine that runs Docker. So that is called Docker image. So we have two things now. Onto my bare metal, the Linux server, I'm installing Docker. Let me bring up the Docker right here instead of having it in the corner. I'm installing Docker onto the server, and Docker is responsible for creating the image we said. So how does it create? So we spoke a little bit about images. Okay. I also mentioned that Docker will package the entire application along with the operating system. So this is the base operating system. Let's say for my reservation API, I want the base operating system to be Linux. And on top of it, I want to wrap up the binaries and dependencies. That is the binaries, that is nothing but, let's call it as probably file system. We can call that a file system as well. It combination of libraries plus dependencies. And on top of it, I have the application itself running, right? So I will not put the application that's running. I will just leave it at this. So what I had drawn here is nothing but a Docker image in form of layers. So every Docker image that we create for Docker to spin up a container is a is nothing but a wrapper of layers of uh, a base OS followed by the file system, which could be libraries and such. So you're packaging your entire application along with the environment. And as I mentioned, it consists of file system that is available for to the application and other metadata, so that once you deploy that image, the container will be up and running into any server that you deploy to. So what I said is I will go ahead and install the Docker onto my bare metal server, and I write something called Docker file. And this Docker file contains set of instructions to create the Docker image. So the next time if I want to create a container onto this bare metal server, I can have the image deployed onto the server directly, which is it is going to be spun up as a container instance. So in my demonstration, I'm going to talk about container instance, how that is made possible. So let me bring up this container instance right here. So once I pull the image and I can deploy it onto Azure Container Instance. So where is this coming from? So I was talking about bare metal so far, but think about it, 8-core CPU and you have 4 containers running. So would you be able to scale more than the 4-core, right? If the reservation API is going to be, scaled during peak season. So would your server be able to scale? Maybe not, right? So then you will have to additionally procure servers. That's where I'm saying rather than going and deploying the container from this Docker image to this bare metal, I'm using Azure Container Instance in the cloud. So that way I can scale many number of container instances depending upon the load. But then I said that this image is portable. Today, I want to use Azure Container Instance. Tomorrow, I want to use a container instance running in another cloud. So how do I enable that? So instead of having this Docker image sitting in my local, because all I did is I installed Docker in my bare metal server, and then I created a Docker file, which are a set of instructions to create this Docker image. Again, I'm reiterating, and this Docker image is a collection of layers. You know that would map up your entire application. It is nothing but a blueprint of your entire application. But I also mentioned it is portable. To achieve portability for containers, we introduce the Azure Container Registry. So Azure Container Registry is a repository of Docker images. You can push this Docker image to Azure Container Registry. It's a private repository, fully secure. So in case of production images, you can rest assured that your Docker image is safe because it works on RBAC, role-based access, and with the least privilege. So systems or services with the appropriate RBAC can only access the registry. So from the registry, if you want to deploy a container from the registry, you can pull the same image, the Docker image, and then deploy onto the Azure Container Instance. So this is the overall flow, guys. So let's go ahead and jump into understanding how we create a Docker image. Again, to let you know, the Docker image has been widely adopted in the industry. Uh, so Open Container Initiative, OCI, was born to create an open industry standard around container formats and runtimes. So Docker is part of the initiative. There are other um, similar um, uh, softwares like Rocket. However, most of the cloud providers supports Docker images, which means in onto whichever um, server the container is to be deployed, that server should contain Docker running. Okay. Otherwise, the Docker container cannot be created onto that server. So that's one thing to remember. Whenever you're using Docker image, the server onto which you're deploying that Docker image to create a container should run Docker in it. Now I have Docker running in my local right here, and I have a reservation API already available, and I have the source. I'm not going to talk much about how the API has been implemented, but let's look at the dependencies, right? So we have the source in which I have the hotel reservation system and hotel reservation system types. The hotel reservation system types is reference into hotel reservation system. If you are from a .NET background, you'd be able to understand, but then you don't have to really be from a .NET background to understand what I'm talking in terms of container creation, but only to kind of look into the code, right? The CS project file has been referenced here. Hotel reservation system type has been referenced into hotel reservation system as well. So let's go ahead and create a Docker file to start with. I'll go step by step on creating a Docker file. If you want, you can also take notes. So let's, for now, I'm just not looking into the chat for any of your question. Once we are complete with this demonstration, I will look into your chat. So a Docker file is an extension-less file, guys. You need to create an extension-less file. You can name anything, but generally it is named as Docker file. So I'm creating an extension-less file inside the source folder. And let me go in and I will see the Docker file right here. So I will bring set of instructions and I'll explain you one by one. So I'll start with from. If you remember, I mentioned about a base image from acrmicrosoft.com followed by .NET Core SDK 2.2 is the base image, which would internally have a layer of the base operating system along with its runtime. So this image is already available in Docker Hub. So again, like I will tell you what Docker Hub is. Like how I spoke about Azure Container Registry, which is a repository of collection of Docker images, and it's a private repository. We have a public repository that is run by Docker itself, which is called Docker Hub. So there are a lot of images, base images. You can think of them like open source images. Anybody can pull those base images. What I have done is I have pulled the base image from Docker Hub, and I am layering the application dependencies and libraries onto this base image, one after the other. So this is what I'm defining into this Docker file. So when I execute this Docker file, and who is going to execute it? Docker is going to do that. When Docker is executing, it is nothing but it's building this Docker file. While it builds, it will go and create those layers on top of one another onto this base image itself. So for performing this, Docker will create intermediary containers. You can think of it like intermediary build agents. And that build agent needs to prepare itself to go and package all of these units, right? So I'm instructing Docker to create a working directory called source. And into the source, I'm asking Docker to copy the hotel reservation system CS project file from my local host, which is my laptop, to the destination hotel reservation system folder in the intermediary container, or like a build agent. And again, CS project file for the hotel reservation system types as well. And then I'm saying .NET restore. What it will do is it will restore all the dependencies that is defined in the CS project file. So the next set of commands, I'm asking to copy from source to destination. Copy the entire folder from source to destination. SRC folder from my local to the intermediary container, which will eventually wrap up that layer of image, right? And then I'm going to change the work directory to source hotel reservation system. Finally, I'm saying run .NET build. So like how in a VS Code, like in any IDE, it could be Eclipse or VS Code, like how we would say .NET build, like I would generally put a .NET build command, right? Similarly, I'm asking the build agent, which is the intermediary container, to perform a .NET build for this particular project. Once the compiled files are ready, then I'm instructing to do a Docker run. I'm sorry, Docker publish. Run would be the final stage. Docker publish. So what Docker, .NET run would, sorry, Docker .NET publish would do is to publish the DLLs. So let's say that I'm publishing the hotel reservation system DLL. If you can think of it like a jar file if you're from a Java background. So publish would have published the DLL, and the DLL is available in the app folder. And I'm saying like after uh, the final step of having the DLL, create an endpoint to run to perform a .NET run followed by the DLL. So what this step would do is once you're deploying this container image to create that golden container, onto that container, this DLL will be brought up and running, like how you will write a .NET run command in your local. That will bring up your application in the local host when you have exposed to port 80, right? Similarly, in that golden container, the DLL will be up and running, bringing up my reservation API and exposing it into the containers port 80. In my local host, I have to still, while I'm doing a Docker run, I have to define what port in my local I have to expose it to. So in the container, it will open up port 80 to, uh, for the container to receive HTTP requests. Okay. So once this is done, let me go ahead and do a Docker build command there. Docker build -t, giving the name of the image, reservation API dot. So I'm saying that go ahead and pick the Docker file from this location. And if you can see my screen, sorry about this one. So you can see my screen, all of the execution of the instructions that I had written in my Docker file are being performed by Docker, because I gave a Docker build command. And this Docker, again, I have installed Docker, and there is this Docker daemon server that is running in my local all the time. And every instruction that I give from the command line to Docker is a Docker client API call that kind of pings the daemon server and creates the image for me. I hope this is almost getting complete. Yeah, so the image is created. The reservation API is right here. To view the image, I will just say Docker image list as a reservation API image that's available. So we'll not be able to view the image. However, we can run the image to deploy a container. Right now, I'm deploying this container in my local, in my laptop itself. Docker run hyphen port. I want to open it to port 7081 and hyphen docker. And name of the container, I want to give reservation container followed by the image name. You can see that how immediately a container is created for me. Like, and it's, as I told you, it's just a execution of a process, a custom process that is running in my, uh, it's an execution for my operating system. The kernel is executing that process in my operating system, so it's pretty fast. So I can go to the browser and automatically I'll be able to bring up the uh, container instance. Localhost, let me, I have already one. So you can see that the reservation API is returning back certain information. I can give the reservation ID number. It is providing me certain information, right? So the API is up and running in my container that's running locally. But my end state, as I had drawn in the diagram, is to push it to Azure Container Registry. And from the registry, I want to pull the container image and deploy it into the instance so as to make this image more portable. It does not, it shouldn't be residing in my local itself. I should place it in some external repository. So let's quickly go ahead and do that. So I will open up my portal. Check where my portal is. Yeah. So in my portal, I'll create an Azure Container Registry. So for creating a registry, I need to create a resource group to start with. It's a WIT container resource group. I want to create in East US. Stock keeping unit can be standard. And I'll just say create. This is going to take a bit of time. So while this is coming up in the background, let's go ahead and create the image to be compatible to push it into this particular registry. Okay. Okay, the resource is created. So what's important to me is the containers login server. So I need to also enable admin user right here. So it will provide me a password as well. The username is nothing but the name of the repository. Along with that, I need the password. The reason is I want to log in into this ACR from my local. And I need to have this login server details. So let this be like this. Look, like while I'm creating the tagging of the image, I will use those details. So the reservation image that I have created currently is sitting in my local. The idea is to move it into ACR. I need to convert this image into ACR compatible image. So which I'll use this command, docker tag name of the image, which is reservation API, followed by the login server with repo Azure is azure.cr.io, and I want to give the name ACR with image. So Once the tagging has happened, I need to use this name to push the image to ACR. But before that, remember I have to log in into ACR, right? So I will say Docker login and give the ACR server name. ACR is nothing but Azure Container Registry. It will ask for username and password. So I can provide the user details. Login is successful. Let's do the last step of pushing this ACR image to Azure. Docker push followed by image. So it is preparing to push to the repository. So this will take a bit of time. The reason being the current container image that we have created is not optimized. We have not used multi stages to this container, image creation. So the Docker file will go ahead and, the Docker will go ahead and um, execute these set of instructions, and every output of each of these instruction will be layered onto the image. So it will contain my entire application libraries, the the dependent libraries and the compiled files, all of that, which is not necessary for me. What I need for a container to bring up an application, reservation system application, is only this DLL. But I have not optimized on creating this Docker file. But then, as you go along and as you learn on how to optimize on Docker image creation, you will use a concept called multi stages. So from the first stage, you go to the next stage, and the output of the next stage will go to the third stage. And the final stage would use the output along with a base image. So what gets wrapped up is only the DLL along with a base image. So that's called multi-stage Docker file, right? So since I've not optimized it at the moment, it is going to take some time and my container image would be heavy. So while this is happening, let's go back to my explanation and I will have you think about one thing. Now that we have created a container image and we are going to deploy onto this container instance, right? One of you had asked, like, how will each of these services talk to each other? So it's good that I have deploying a reservation API. I will also go ahead and use the same methodology to deploy payment API, notification API, and bookings API. But how do I ensure that the APIs are talking to each other? My system is hung. So I hope you're able to hear me. So how do I ensure that my APIs are talking to each other? That is where we have a container orchestration layer called Kubernetes. So we use Kubernetes to perform that uh, communication between the microservices. And it is not just performing the communication, it is also managing the containers. So we have AKS, which would perform uh, container orchestration along with managing. So in AKS, we have the master node and worker nodes. Docker will be installed onto both the master node and worker nodes. And when you perform instruction onto AKS, it would instruct Docker to create containers, but who is managing and orchestrating it? Kubernetes architecture is doing that. So we will be covering Kubernetes in our next section, as in for our next session. But for now, one of your answer is we'll have to use Kubernetes for communication between microservices. So the process is taking some time. I just want to call out certain shortcomings of the Docker, right? So, as I told you, Docker can reside in only one server. It is native to a server. What if you want to deploy the same microservices instances to other server and have them talk to each other? Docker cannot perform that. And these containers that you create in one single server are bound to the network of that server. It talks through the same network bridge that is running in that Linux system. So uh, that is the reason why we are using Kubernetes to perform that network level communication, or opening up the network, bridging the network between multiple containers running in different servers. You can think of servers as nodes. We call as nodes in Kubernetes architecture. Communication between different nodes, all of that is handled by Kubernetes. So the next step is to show you, once the image is pushed, how I can bring up that image in a deploy that image in the container instance. So my system is actually gone a bit slow. So I can create a container instance in Azure. So even if I'm not able to successfully, demonstrate on it, I will show you the service. So I can create a container instance by come on, this has become very slow. So I can choose the same resource group here, the logical grouping of all the resources that belong to uh, to this single application topology. You can group them within the resource group. I just created one resource group with session, and I can give a container name. So it is a unique name. And Azure container instances are again very lightweight, and it gives you a fully qualified domain name. You can access it from the internet. Also, I can share you the link once I create it successfully, but let's see. So I can choose the Azure Container Registry and Vit repo, and I can directly pick the image from Vit repo. Right now, it doesn't show up any image because unfortunately the process is still running, and it is surprisingly, it is taking a lot of time today, but I think it's almost getting done. Even for container instances in cloud, you'll have to remember that uh, if you want to attach volume, you'll have to additionally attach it from the volume options in the cloud. You can attach with Azure File Share for storage. So here I'm saying that I want a one virtual CPU with 1.5 GB memory. I can change the size for, I can have like, I have multiple container options depending upon the requirement for my API. I could change them. For my reservation API, one core is still fine. But if I want to make changes, I could still do that. Come on, it's almost. So once the image is pushed, I can see the image in the repository. Let me refresh. If I refresh, this thing will reload again. So it has already pushed it. Hmm. I need to refresh. Okay, let's. Container. I'm using Azure Container Registry that I just created. Um, right now I got the ACR with image. I can choose the image and I said review create. Yes. So once the deployment has happened, I can access the reservation API in the cloud as well. Similarly, I can create multiple of these containers, but then rather than creating multiple containers for each of the API, I would have all of the containers create using AKS, right? So I will define the deployment template and ask AKS to internally, talk to Docker and create the containers and have AKS orchestrate all the containers. So this is also taking a bit of time, but I'll share the URL once it is ready so that you can access the container, the reservation API as well. So with that, there is been a bit of lag with the network, so I was not able to effectively walk you through on the last part of it, but it is pretty much we have covered most of the aspects that I wanted to cover today. What I wanted to show you finally is before we wrap up for the session, we want to run through a video, and we highly encourage you to go and update your LinkedIn profile with Azure skills. So if you have taken Azure certifications or you have taken Azure challenges, please make sure to update your LinkedIn profile with Azure, Microsoft Azure skills. So let's go through the video and then we will take up the questions.
Updating your LinkedIn profile increases opportunities to attract recruiters and potential employers for job opportunities. Let's head to LinkedIn. And here you would need to click on the downward arrow under your profile. Click View Profile. Follow this up by clicking Skills, and on this pop up, go ahead and update all the correct skills that you currently have and are continuously learning through various training channels. Think of those keywords like Microsoft, Microsoft Azure, cloud computing, data analytics, Power BI, and many more. Doing this is going to make you visible for all those job opportunities that require these skill sets.
Perfect. That's all I wanted to share, guys. Yeah, the resource is deployed. I will share the link with you so that you can also, um, you know, uh, access the reservation API. But let's not spend time on this. Let's go ahead and open up for questions. Do you guys have question? I think some of the questions like already answered, like the ones on the top are already answered while I was explaining. Is there any further question for me and Juliet?
Yes, one of them have a question on whether do we have student account on Azure for learning? Yes, we do have a student account. So we'll share you the link, uh, provided you should have an .edu. So using that, you can sign and you can get a free account for 12 months. All right. So we'll ping you the link. Yes. DLL is something. Is DLL something like jar and war in Java? Yes. Yes.
Yes, absolutely. Okay, so gosh, I'm not able to see the window where I can post this URL, guys. I'm sorry. Um,
Put it.
private chat. Let me try once more. So, are you able to post chat messages, Juliet?
Yes.
Let's check
One
once. I
second.
can pass it on to you. Suddenly uh, the tool became like grayed
Yes.
out for me.
Okay, we have a question. Can we deploy both front-end and back-end application in a single container and then the container in ACR?
As a best practice, we are suggesting not to deploy a front end and a back end. In fact, you cannot deploy a front end and back end in the same container. You need to deploy it as two different containers. However, you cannot even deploy them as a single container group because that's not a good practice. Along with a container, like a front end container, you can have the help of you know, what do we say, services such as logging service or proxy services. Okay, so ensure that your um, containers are demarcated and your front end is load balanced and your back end is load balanced by an internal load balancer and such.
Okay, what kind of questions are asked in the certification? So that is related to the certification that you are trying to take. If it is an AZ900, it is related to Azure fundamentals. And if it is 104, which is an administrator certification, or if you're trying to take some, architect related certifications, then it is more of, case studies and it is practical oriented. All right. There are chances that you could get lab exercises also for your certification. All right. Okay, we have a question. What is the use of migration assistant tool in Azure websites? See, there is a tool which we call it as app service migration assistant tool, which is part of Azure Migrate. Let's assume you have an on-premise application and you want to migrate that particular application to an Azure app service. So before migrating, using this tool, you can run an assessment on whether this particular application can be migrated. And if it also, what this tool does is it runs an assessment on the application that is deployed inside the IIS, and then it produces a report which says, whether it can be migrated or not. If not, what are the errors due to which it cannot be migrated, and are there any warnings? And what are the, remediations that you could take to migrate that particular application to Azure? All right. Okay. And we have a question. Video streaming or play game online type website can be deployed in Azure or not? Yes, we can do it. So we have a service called as, media services with which you could do it. Yes, we can.
Any further questions on microservices? And it's a very interesting topic for a cloud native application delivery. We will plan for another session on Kubernetes, which will then give you a broader visibility around how containers can communicate with each other. To your valid question, right? Can a database and a front end can reside in the same? So in Kubernetes, we use something called pods, and we wrap up the front end and back end as two different pods. All cool, concepts we'll cover in the next section.
Preeti, we have a question. At runtime, can we post requests into the container?
Yes, of course, we could, you can open up the specific ports. If you open up port 80 or 443, you can send HTTP and HTTP requests to the containers. See, it would act as good as how you are deploying your application in your laptop, in your local or in your virtual machine. As I told you, container is uh, it contains your entire infrastructure, so that you can tear down your infrastructure and spin up the infrastructure in whichever whether it's on prem, whether it's in cloud. That portability comes in. At the same time, you have another concept called immutability. In You create a container image and deploy it 100 times, it will go ahead and create that infrastructure along with your application up and running. In those 100 different instances, it will be the same, like how you want to be. So you will define all the port that needs to be open in the Docker image itself. Okay. I guess it's time to wrap up then.
Yes.
Cool. Thank you so much for joining us. It has been a wonderful session. Looking forward to meet you guys on another session. Have a good evening ahead.
Thank you. Have a good weekend.